Hello again. So now we're going to talk about kinetic energy. Okay. So for this one, it's definitely helpful to start thinking about pain. So kinetic energy means motion. So this is the energy of motion. So the easiest way to think about it is I have something that's moving. What are the ways that it will be more painful if this moving object hits you? Okay? What are two ways that you can change how painful it would be? Okay, one would be if I just have a bigger object, right? Basketball is going to hurt you more if it hits you in the face than a marker, right? The second way is what? Yeah, how fast it's moving, right? Even though a baseball is pretty small, if it hits you, it's really going to hurt because people can throw it really hard, right? So what are the two things that kinetic energy depends on? Mass and velocity. Okay? So remember, velocity, or kinetic energy, is a energy, okay? And this actually means that it's scalar. So this isn't something we really talked about with the work section, but energy and work are both scalar. What that means is they don't have a direction. It's just a property about something, okay? So I don't say a kinetic energy is moving in a right-left direction. That doesn't matter. All we care about is that it has kinetic energy in general, okay? Units, once again, joules, just like work. So energy, work, they all have the units of joules. Now, let's go back to our mass and velocity. Which one do we think is more important? Okay? Think about it. If a dump truck hits you, but it's moving very, very slowly, does it hurt? It usually doesn't hurt that much if it's moving really slowly, right? It's just kind of a push. Okay? So velocity actually ends up being more important. Okay? So let's go ahead and move on. Okay, so velocity is more important, so let's go ahead and build our equation. So we have Ke equals, we know we have mass, we know how we have velocity, and we know velocity is more important, so this one is squared. Okay, and then we also have this 1/2 out front. The reason for the 1/2 has to do with calculus, so for right now, you can just take it on faith. Trust me, the formula is 1/2 mv squared. If you don't trust me, I guess you can look on your formula sheet. So let's look at this first question. We have a 6 kg cat runs after a mouse at 10 meters per second. What is the cat's kinetic energy? So what is the mass? Yes, m equals 6 kg. What's the velocity? Correct, v equals 10 meters per second. So let's go ahead and write our formula. Remember, it is important to write out Ke equals 1/2 mv squared. Okay, so I get Ke equals 1/2 times 6 times 10 squared. So that just equals 300 joules. Okay, not too bad, right? Let's look at number 4. A 7 kg bowling ball moves at 3 meters per second. How much kinetic energy does it have? And then we want to know how fast does a 2.5 gram table tennis ball need to move in order to have the same kinetic energy? And is this speed reasonable? Okay, so let's go ahead and just solve the bowling ball part first. Okay, so let's write down our variables. What's our mass? Yeah, m for the bowling ball is 7 kg. What is the velocity? Velocity for the bowling ball is 3. So let's go ahead and write out our formula. It is important to write it out. Ke equals 1/2 mv squared. So Ke equals 1/2 times mass, which is 7 times 3 squared. So that will be 3.5. This will be 9. So it's 27. So this should be 31.5 joules. Okay, if I got it wrong, I'm sorry. It would be a good idea to go ahead and check with their calculator just to make sure that I'm getting the correct answer here. So now let's look at the second half. So this is about the table tennis. In this one, what are we solving for? what does it ask about the table tennis ball? How fast? So in this part, we're actually looking for velocity instead of KE. So let's go ahead and write down our variables. So m equals 2.45, but this is grams. So we need to figure out how many kg that is. So I need to move my decimal place 3 times. 1, 2, 3. So that'd be 0.00245. Okay? And then I need to find, so my KE equals 31.5 joules. Okay? And I'm trying to find velocity. So let's write down our formula. KE equals 1/2 mv squared. So KE, oops. I don't think I got that right now. So we have 31.5 equals 1/2 times mass, which is 0.00245 v squared. Now I'll multiply this by 2, so I'll get 63 equals 0.00245 v squared, and then I'll need to solve for v. If I recall correctly, the velocity is a very high number, so it's not very reasonable speed, which makes sense. A bowling ball is really heavy, and a table tennis ball is very light. So in order to have it hit you and be the same level of pain, it would need to be going very fast, right? Okay, so I will see you back for the next section.